Hello everyone, in this video I'll be going through a differentiation question at NCA level 3. There are two ways to approach this question. One is using inverse trig differentiation, and the second way is to do compound angles and then quotient rule. In NCA level 3 and scholarship, I don't think inverse trig differentiation is covered in the syllabus, but it is in AS and A level mathematics. So I'll go through both ways. But both ways has similar approach. In this question, it says in a rugby game, a try scored 15 meters from the left-hand goalpost, and the conversion kick, all of that stuff. Essentially, we have to work with this diagram, and we're trying to find at what distance d do we maximize the angle theta over here. And the first thing we're gonna do is invent or bring in a new variable, which is our beta, and beta is this whole angle added together, alpha plus theta. So we can say the angle theta, which is what we want to find, what we want to maximize, work with, is equal to beta minus alpha. Right, makes sense? From this diagram, we can also say beta is equal to tan inverse of 20.4 over d, right? Because beta equals tan inverse of opposite over adjacent. And hence we can also say alpha is equal to the tan inverse of 15 over d. Alright. We can work with that. So we'll go through the first way, which is theta equals beta minus alpha. So theta equals tan inverse of 20.4 over d minus tan inverse of 15 over d. Now we can take the derivative of theta with respect to d, because we're going to take the derivative of theta with respect to d because we're working with theta and d. This is going to be first let's revise that the derivative of tan inverse of x with respect to x is equal to 1 over 1 plus x squared. So the derivative of tan inverse of 20.4 over d would be 1 over 1 plus 20.4 over d squared. And then because of chain rule, we're going to multiply the derivative of the inside function, which would be negative 20.4 over d squared over d squared. Alright, and then we're going to minus the derivative of tan inverse of 15 over d, which will be 1 over 1 plus 15 over d squared multiplied by the derivative of the inside function. We're going to simplify this. This becomes negative 20.4 over d squared times 1 plus 20.4 over d squared, plus, because the two negatives makes a positive, 15 over d squared, 1 plus 15 over d squared. This is going to be 1 times d squared is d squared, and if we expand this bracket, it becomes 20.4 squared over d squared, and we're multiplying a d squared outside the bracket, which will leave us with 20.4 squared. And this is same thing, but 15 squared. So this to 0 for stationary point. We get 15 over d squared plus 15 squared is equal to 20.4 over d squared plus 20.4 squared. Cross multiply, 15d squared plus 15 times 20.4 squared equals 20.4d squared plus 20.4 times 15 squared. Bring d squared onto one side, 5.4 d squared equals 20.4, sorry, equals 15 times 20.4 squared minus 20.4 times 15 squared. So 5.4d squared equals to 1652.4. So d squared equals 306. D equals root 306, which is around 17.49 meters. Right, so this is a very quick way using inverse tan derivatives. But this is not covered in NCEA, and now we're going to go through our second way, which is probably what NCEA wants from us. We're going to use the same information, but this time, instead of using tan alpha and beta as tan inverse, we'll do tan of beta equals 20.4 over d, and tan of alpha equals 15 over d. Alright? Hence, we can say, use the same piece of information, theta equals beta minus alpha. So we're going to take the tangent on both sides, becomes tan theta equals tan of beta minus alpha. So we're going to use compound angles on the right hand side. Tan beta minus alpha will be tan beta minus tan alpha over 1 plus tan beta tan alpha. Remind ourselves, tan beta is equal to 20.4 over d, and tan alpha is 15 over d. Just sub in the value from here. We'll get 20.4 over d minus 15 over d all over 1 plus 20.4 over d times 15 over d. This becomes 5.4 over d on the top, and at the bottom it will be 1 plus 15 times 20.4, 306 over d squared. I'm gonna keep simplifying. It becomes not 5.4 over d over 306 plus d squared over d squared. Now this becomes 5.4 over d times d squared. We're dividing by a fraction, so we multiply the reciprocal of the fraction. D cancel out and the square goes. It becomes 5.4 d over 306 plus d squared. And this is tan theta. Now, we're trying to find the distance d that maximizes theta, but we're working in the first quadrant here, meaning we're working between 0 and 90 degrees. And obviously, theta will be between 0 and 90 degrees. There's no way that theta could be more than 90 degrees, obviously. So, we can draw a tan graph. This is our 90 degrees here. Goes like that. That's how y equals tan x. If we're working between 0 degrees and 90 degrees, tan theta increases as theta increases, right? So when theta increases, tan theta increases. If we maximize this theta, our tan theta will also maximize. This means if we find the maximum of tan theta, it will also give us the maximum of theta. So to maximize theta, we can just maximize tan theta. So we don't have to do implicit here, so, meaning like differentiate with respect to d on both sides, because it's a function on both sides. Instead, we can just say tan of theta is just a function of d. And that's true, because tan of theta is a function that we have in terms of d. So instead, we can just say f of d equals 5.4d over 306 plus d squared. And if we maximize f, the function of d, we can maximize theta. right? So how do we do that? We just take the derivative of it. And now I have to use the long vigorous quotient rule stuff. And we do this by squaring the bottom, bringing the bottom line to the top, multiply it by the derivative of the top line, minus top line, multiply the derivative of the bottom line, which is just 2d. And simplify this, we can pull out a common factor of 5.4 on the top. It becomes 5.4 equals 306 plus d squared minus 2d squared, because 2d times d, all over 306 plus d squared. And simplifying this, it becomes 5.4 times 306 minus d squared over 306 plus that drop is a square, everything d squared squared. Alright, I consider this equal to 0 for a stationary point. We don't have to worry about what's on the bottom line, because the bottom line will always be, it won't be 0, and it will always be positive, because d squared is positive, so 306 plus d squared is positive, and we're squaring the whole thing, so it must be positive. Setting this into equal to 0, we get 5.4 times 306 minus d squared, so the top line equals 0. Divide both sides by 5.4, we get 306 minus d squared equals 0. So d squared equals 306. D equals square root of 306, which is 17.49, approximately 17.49 meters. And that would be the same as what we got here. So there it is, solved. It's good to learn the inverse tangent derivative, but I guess you can still live with quotient rule and all that stuff, but it's way longer, as you can see. Yeah, thanks for watching.